Hi everyone, today I'm gonna teach you how to convert from other systems to decimal. So we have only one rule for this one and we're going to apply it for different systems. And let me explain for you the rule. For example, if you had this number which is x and this number is in base y, so you want to convert it to decimal number, so you're going to have y power 0, starting with power 0, and you multiply it with the first digit of your number. For example, if x consists of x power x sub 0, x sub 1, x sub 2, so you'll multiply this one with the first digit and then you add it, and here you'll increment your exponent. So it was here y power 0, this time it will be y power 1, and here you multiply it with the second digit and then add it again, incrementing the power. You will put the power for the base of your system, not for the digits, okay? This is a really important part. And then you will add all of these numbers together to get the result in decimal system. And if you had like a fraction part or any numbers after the floating point, you will use the same base but with a negative exponent, and each time the exponent will be like you will keep decreasing the exponent. So starting here with y power -1, then you'll subtract -2 and so on. So now let's start with our first example, converting from octal to decimal. We have this number in octal system and we want to convert it to decimal. So here our first digit is 7, so we will multiply 8 because here we're dealing with octal, and as you know, octal is base 8 system, so we take the base, and in our example the base is 8, so 8 power 0 times 7. Then we will add it to 8 power 1. As we said previously, we'll keep incrementing the power each time we will have another digit. So here 8 power 1 times our next digit, which is 2, then 8 power 2 times 1, and we add all of them together to get the result in decimal. So the answer is 87. So 127 in octal is equivalent to 87 in decimal system. So hope this example is clear, and you can really pause the video and try the examples with yourself and then double check with us. So try this one, and when you're done, just double check with us. Here we should convert from binary to decimal. We have this binary number. I told you previously that there is a way to convert from binary to decimal, just to fill each bit, and each time you will increment the power. You can use this way, and also you can use the way that I'm going to explain right now. We are going to use the rule that we use for the octal example, because this rule, like, you can apply it for any system like base 3, base 7, hexadecimal, any base system, okay? Like any system in the numbering system. So let's just try this one, starting with 2 power 0 and then multiplying it by 1, because 1 is our first digit here. Keep in mind that you should start from the right to the left, okay? Because if you really did the opposite, you will like definitely get a wrong answer. So 2 power 0 times 1, then increment the exponent, 0, then 2 power 2 times 1. Keep incrementing, times 1 also. And let's get the answer. I'm only going to calculate the ones like the number with which is multiplying it with 1, because anything times 0 will give me 0. And to save time, not wasting our time, so we'll get 93. So this number in binary is equivalent to 93 in decimal system. You can use this way or the previous one that I have explained in the previous videos. And now also we have the third example. Also, you can pause the video and try it with yourself and then double check with us. We have this number and hexadecimal, and you want to convert it to decimal. So for this one, we're going to do some changes, or not like a very slight changes here, because we're dealing with decimal, and in the previous examples, all the digits that we dealt with, they were actually in the decimal system. Like, as you know, decimal, like in decimal system, we deal with numbers that consist of 0 starting from 0 up to 9, and octal starts from 0 up to 7, as you know, and binary 0 and 2 only. So all of these digits actually are in decimal system, but here in hexadecimal, C is unknown in in decimal, and F as well. So we need to know what is the equivalent number for C and F. So the equivalent ones here is C is equivalent to 12 and F is equivalent to 15. If you don't know, it's easy, just starting from A is equivalent to 10, then B 11, C is 12, D is 13, E is 14, and F is 15. Okay, so we said that C is 12 and F is 15. Now we can get back to our example and start converting. So starting with the first one, 16 power 0 times 9 with the first digit, and then we will add it to, you don't take C, you take the value of C in decimal system. So 16 power 1 times 12, then you add it to 16 power 2, incrementing the exponent of our base. Yeah, and I forgot to tell you that hexadecimal, as we said previously, 16, like base 16 system, so that's why we're dealing with 16 as the base system of the number, as it's the base of our system. So 16 power 2 times 3 plus this one 3, and the value of F, and we add all of them together. So this number is equivalent to 62409 in decimal system, so you can rewrite it again. Decimal is equivalent to 62409 and decimal. Okay, so what if the base was different, like unfamiliar base, not Not for example octal or binary or hexadecimal. For example, base 5, base 4, base 3. You're going to apply the same rule. So we have this number. We'll do the same. Starting, this is our, so it's base 5, so the number that will be raised to any exponent will be 5, not the digit. It's always the base of the system. Okay, so starting with 5 power 0 times 1, then we add to 5 power 1 times 0, then 5 power 2 times 3, then 5 power 3 times 4, and we add all of them together. So the number is 576 in decimal system. And also you can write it again like that. And this is the end of our video. Thanks for watching.